In this video, we're going to look at another derivation. We will prove this theorem here. This is another one of De Morgan's laws. This is the other direction of the one that we proved in the video before last. So here we're showing that this way of if this is true, right, not A and not B, then this other way of symbolizing neither nor is true. So it's a theorem, so I've entered it into the bottom of the derivation, and it's a conditional, so we're going to derive it by conditional introduction, and I've already set up for that, right? Set up the subderivation where we have the antecedent as an assumption for conditional introduction, and the consequent is at the bottom of the subderivation. Now, line one here is a conjunction. So what we may as well do is just work top down for a second, and we'll break this up using conjunction elimination. So this will be one conjunction elimination and two conjunction elimination. And at this point, since we've split this up, we can basically just ignore line one from now on and focus on these two, right? The two conjunctions that we've pulled out of there. Um, Now what we've got left here is just these two negated sentence letters. We can't do anything meaningfully top down anymore. So we're going to have to go back to working bottom up. The goal sentence we have here is a negated disjunction. And since it's a negated compound sentence, the most likely way that we're going to be able to derive it is negation introduction. So we will set up to do that. We will need a new subderivation. It's going to start with the by assuming A or B for negation introduction. Okay. Now the lines that we have here at the top of the derivation are we have A or B, not A and not B. And these are inconsistent, right? You can probably see that, right? This is going to be true if at least one of A or B is true. A is not true and B is not true. So it's not possible for all three of these to be true. But if you want to verify this, you can actually just run a truth table on the three sentences. And if you construct the truth table for them, you can just verify, right? There's no line in the truth table where all three of those sentences are true. So the set is inconsistent. So we know that it's an inconsistent set. And if it's an inconsistent set, then we know that it is possible to derive a um, a pair of sentences from it such that one is going to be the negation of the other. We know that that's possible. We don't have that explicit contradiction here yet. So the next task is going to be deriving that explicit contradiction somehow. So that's the next thing that we need to figure out. So here's a first stab at trying to get that contradiction, right? That we need to end this negation introduction subderivation. So it's based on the reasoning that we have this disjunction up here on line 4. And so we could set up for disjunction elimination. So we set up the two subderivations where we assume A and B, right? The two disjuncts. And then we've got A and B, and up here we have not A and not B. So then we can just reiterate A and not A here, and we can reiterate B and not B here. And look, here we've got sentences of the form Q and not Q. Here we've got sentences of the form Q and not Q. So we've got explicit contradictions. But we actually have a real problem here. And the problem is it's the disjunction elimination rule, right? What the rule says is that what you need to apply the rule is you need disjunction, you need two subderivations, and then you need the same line in each of the subderivations. And we don't have that in this case. We've got a contradiction in each subderivation, but we don't have the same contradiction in them. In order to apply the rule, we need to have the same sentence in each one of them. So yeah, so that isn't, so we can't actually apply disjunction elimination. And each of these contradictions, they're each behind an extra scope line, right? In order to end this subderivation here, we need a contradiction that's in this subderivation. So it's got to be in this column right here. And we don't have that. These ones are behind an extra scope line. And so they won't actually help us do that. We need to find some way of pulling a contradiction out of here and getting it over into here. Okay, so how are we going to approach this? Well, the thing is, I mean, remember the principle of explosion, right? If you have an explicit contradiction, you can prove anything you want. And if we set things up for disjunction elimination, we're going to have explicit contradictions inside these subderivations. So what we can do then is this. Within these subderivations, we can prove any sentence we want. So we just pick a sentence that contradicts something that we have in previous parts of our derivation. So we would pick a sentence that contradicts not A, not B, or A or B. Infer that by disjunction elimination. And then we just reiterate one of these three lines. We'll have the contradiction that we need to end this subderivation, and we'll be able to get it out with disjunction elimination. So we're going to set things up to do that. We'll use A as that's going to be the way that we're going to get the our contradiction. We could use I mean either A or B works very nicely. We could actually derive not A or B in these, but the derivation ends up being quite a bit longer if you do it that way. So this stuff is not helping us. So we're just going to delete all of this and delete this line number. Okay. So to derive A in each of these subderivations, we will go like this. Here, we're going to get it by reiteration. Oops, 5R. So there, we've derived A in the first subderivation. Down here, you know what, let's actually just move this thing up a little bit. I guess I will have to get rid of that scope line, won't I? Okay. Here, in fact, we know this is going to be line 7. I can just write that in now. Here, what we'll need to do is we're going to need to introduce a new subderivation where we will we're going to assume not A for negation elimination. And then we will then reiterate B from line 7. Right, so that's 7 reiteration and not B from line 3. So 3 reiteration. That allows us then to infer A by this is 8 to 10 negation elimination. Now we have A in both of the subderivations, which means then that we can infer it here by this is going to be lines, so we cite line 4 and then the two subderivations. So it'll be 4, 5 to 6, what is that then? 7 to 11 or elimination. So we have A here, and then all we need to do then is reiterate line 2, not A, and then to reiteration, and there's our contradiction, and that allows us to end this subderivation here. So we've got this then by negation introduction lines 4 to 13. And then this line here is lines 1 to 14. And then all that would be left is to go through and resize these columns a little bit just to make sure that all the lines fit properly. A couple of things here to note. First of all, here at line 8, we are assuming not A. We already have not A in the derivation here. That probably seems weird that we're assuming something that we already have in the derivation, but it's fine, right? We're doing this in order to prove A by negation and elimination. So, I mean, it's sort of a technical move that we're making, right? It serves a specific purpose. So this is something that's perfectly fine. Another thing to note here is that you can get a contradiction here by reiterating B from line 7 and not B from line 3. You can't get it by reiterating not A from line 8 and then A from line 5. This is a separate subderivation. It's not accessible there. Right, so this is all this here, because of the fact that it's a separate subderivation, it's stuff that you can't touch. So make sure that you don't, mistakenly cross the scope lines when you're dealing with two consecutive subderivations like that. Yeah, this derivation then it ends up being a little bit more complicated than the ones we've been looking at so far, but it's all finished now.